In 1977, NASA launched the Voyager 1 spacecraft with a mission to explore the outer reaches of our solar system and beyond. And now, after 45 years, Voyager 1 has made contact with an unknown force in interstellar space, leaving scientists and space enthusiasts alike in awe. What could this force be? Is it a sign of extraterrestrial life or something else entirely? Join us as we delve deeper into the mysterious discovery made by Voyager 1 in interstellar space. Let's explore how Voyager 1 just made contact with an unknown force in interstellar space. Even though the Earth is a remarkable planet, it is only a little speck in the vast and amazing universe. Technology development has made it possible for people to send satellites and rockets into space, trying to stoke their insatiable curiosity about the universe's mysteries. Even though we have a good understanding of how the universe functions, a lot of knowledge we have is based on conjecture and speculation material. Voyager 1 and Voyager 2 are essential to our understanding of the cosmos because of this. We may not be able to go to the furthest regions of our solar system or interstellar space for many years, but these probes are sending back real-time data that is illuminating them. What happens, though, when the data contains a horrifying warning that alters everything we believe to be true about the universe? Our horizons are still being expanded by the two Voyager probes, which were launched more than 40 years ago. Voyager 1 and 2 have traveled well beyond their planetary objectives, with Voyager 1 traveling more than 5 times farther out and flying by the huge planets in the late 1970s and early 1980s. Voyager 2 and Neptune were not far behind. The tenuous material that fills the enormous distance between and has been penetrated by both spacecraft over the past 10 years. There, the spaceship keeps finding new things. Researchers were shocked by the interstellar magnetic field's intensity and direction, and new information has even sparked a discussion over the geometry and activity of the heliosphere, the solar system's magnetic field. Is this heliosphere more spherical, or is it long adopted the form of a comet? Not even Voyager was the first spacecraft to approach one of the closest big planets. The distinction went to 10 and 11. The Voyagers, on the other hand, were more advanced than the Pioneers and made a lot of surprising discoveries. Titan in 1979, Voyager 2 traveled the scenic path and visited Jupiter, Saturn, Uranus, and Neptune. All appeared between 1981 and 1989. Voyager 2 revealed breathtaking images of the green and blue while observing geysers on Neptune's large moon Triton. After then, the spaceship started its journey into what astronomers refer to as interstellar space. Like the top of the Earth, the Sun's chamber is known as the heliosphere, and its edge is called helio. Tropopause is another name for the troposphere. We didn't know how far away the heliopause was when Voyager was launched, according to Don Garnett of the University of Iowa in Iowa City. While Jupiter is just 5 times further from the Sun than the heliopods, some people thought that they may be even closer. And as the spacecraft raced away, estimations of the distance of the heliopeak grew. Surprisingly, no one knew where the Voyager spacecraft would enter interstellar space. It was not at Jupiter, Saturn, Uranus, or Neptune. Soon after the Neptune encounter, NET said that Voyager had detected indications of Helios's powers. In the distance, the two Voyagers started seeing powerful radio signals at frequencies between 2 and 3 kHz. Several scientists questioned Garnett's explanation for the signals, as such radio waves had never been observed before. His measurement indicated that the helio was depressingly far away. Neptune is just around 30 astronomical units from the Sun, while Pluto is about 40 astronomical units away. In general, Voyager 1 passed through the heliopause on August the 25th, 2012 at a distance of 121.6 astronomical units, almost 4 times Neptune's distance, precisely as predicted by Gwynedd. Yet 2 decades ago, the passage was so contentious that NASA delayed making the announcement for the additional 13 months. Voyager 1 did see some indications that high-energy solar wind particles had traversed the heliopods and disappeared, suggesting that the remainder of the solar wind had likewise disappeared. Also, the intensity of cosmic rays from beyond the solar system that the heliosphere partially block increased. Several scientists were not persuaded by these signals alone after Voyager's passing. Two problems existed. The plasma instrument on Voyager 1 had first failed, rendering it impossible to monitor the rise of particle density. The spaceship is the one that had left the heliosphere and traveled into interstellar space. Second, even though it was meant to, the magnetic field beyond the heliosphere pointed in the other direction. Why the magnetic field beyond the heliosphere aligned with that is still a mystery. The success of Voyager was helped by being within the Sun. Solar storms had already broken out in 2012. The plasma that Voyager 1 was passing through was shocked the next year, causing electrons to vibrate and transmit radio waves to the spacecraft. Voyager 1 was the first spacecraft to enter the interstellar medium as a consequence. The vessel had not, as was widely believed, left the solar system. Now, 1 trillion ice things circle the Sun well beyond the orbits of Neptune and Pluto. A fresh comet is then shown in the sky when one strikes the Sun. The most distant frozen objects are most likely between 63,000 and 126,000 astronomical units, or 1 and 2 light-years away. To give you an accurate comparison, Voyager has traveled farther from the solar system's edge than someone walking 3 miles west from the United States Geographic Center has traveled to the Pacific Ocean. On November 5, 2020, Voyager 2 also traveled past the Hilly Pass. Protons, electrons, and other charged particles collided with the spacecraft and the plasma instrument, which was in use, and it noticed a rise in particles density. The temperature, which was between 30,000 and 50,000 Kelvin, was also observed. This temperature was much higher than the surrounding interstellar medium and was probably caused by plasma compression as it entered the helios. And just like Voyager 1, the spacecraft observed a decrease in the solar wind and an increase in cosmic rays outside the solar system. Nonetheless, the magnetic field remained in place, proving that the results from 6 years earlier were not an accident. The heliosphere's form is altered by the magnetic field's extreme strength. It has a long tail and a comet-like form, according to common belief. While the tail points in the opposite direction from where the solar system moves through the interstellar medium, the nose points in that direction. Regardless of the precise form of the heliosphere, magnetic pressure, which is proportional to the square of the field intensity, squeezes and rounds the heliosphere due to the strength of the interstellar magnetic field. 1 and 2 Voyager keep swerving away from it. 155 astronomical units will separate Voyager 1 from the Sun. The signals and the spacecraft will take longer than 21 hours to reach us by the end of the year, since they've moved at a speed by then. By 2023, Voyager 2 will have traveled 129 astronomical units, surpassing the inactive Pioneer 10 to rank as the second farthest spacecraft ever. Both Voyagers are speeding away in different directions. Both are further away from Earth than either is. Interstellar space data is still being sent. Both can monitor electrons by detecting radio waves produced when solar eruptions cause electrons in the interstellar medium to oscillate. After 45 years of exploration, the Voyagers remain a testament to the incredible achievements of human ingenuity and determination. The sunspot cycle should peak at around 2025, at which point these eruptions should be more frequent. Current measurements show that the interstellar density has risen further from its pre-heliopause level, but no one knows what will happen next. As Voyager 1 continues its journey into the unknown, we can only speculate about the nature of the force it has encountered. Is it a natural phenomenon or something that has been created by intelligent beings? The possibilities are endless, and the implications of these discoveries are far-reaching. What do you think? Could Voyager 1's encounter be the beginning of a new chapter in our understanding of the universe? Let us know in the comments below, and don't forget to subscribe to stay up to date with the latest discoveries in space exploration.